Ish.
Oh, I am.
All right. So let's do experiment number 2. Which is rolling 2 dice. Yes. Now, let's start before actually doing the... I do want to roll the dice today, because I want you guys to see the results. But I want to fuse your last project with this idea, with the dice in your hands, and kind of show you how the whole package comes together. Let's make the distribution like we did up there. So, X is now going to be, and usually when you roll 2 dice, what are you interested in analyzing? Like if you're betting with 2 dice, or if you're playing a board game with 2 dice, what do you do with the numbers you see? You add them up, exactly. So we're going to look at the sum of, I'm going to call them what they're technically called, the pips. It's a great word, pips. It's also a great donut shop in Portland. You ever in Portland? I think it's on Alberta Street. Pips Donuts. One little family-run donut shop. Little tiny donuts like this. So good. Anyway, some of the pips. What can you get? Let's talk about the sample space. We can get 7. Yes. When you're playing craps, if you're taking the pass line bet, you like 7. 7's your friend, yes? What else can you get? What's the other one in craps that you like?
11.
11. 7 and 11 are the 2 good ones for a pass line bet. I'm not going to write them down just yet, because I want to keep this orderly and organized. Is that how we did 1, 2, 3, 4, 5, 6 up there?
So it's like 7, 8, 9, 10, 11, and 12.
Good! What else can you roll?
On the side, and then we can like roll.
In the air, stuck in the air. The die might explode like a Spinal Tap drummer. Brittany!
Two.
Doubles? Give me doubles.
Yeah.
2,
2, 3, 4, 5,
3,
Yeah.
7,
4.
8, 9, 10, 11.
1.
No.
No.
Can't roll a 1. Not with these dice anyway, right? These dice, you have to roll at least a what?
2.
And you can't roll any more than a...
12.
That's on these, on normal casino dice. I think we have our event space, or our sample space, I should say. We have all our events. The smallest possible sum is 2, which is called snake eyes in craps. All the rules have names, which I just recently discovered. 2 snake eyes, I forget most of them. You got 3, 4, 5, 6, 7, 8, 9, 10, 11, and boxcars, which are 12. Yeah. Okay. Now, this assumes that each of the die has 1, 2, 3, 4, 5, and 6 on it. Fair enough? I think it's fair. Okay. How about some probabilities? Any ideas for this right now? So 11 events in the sample space. What should we attribute the probabilities to? What do you think they should be? Josh, what are you thinking?
I think we should measure the probabilities, like how many times that it can occur in the possible outcomes of the adding of the 2 pips.
I think that's a fantastic idea, actually. What most people say is they just say it's 1/11th. They say 1/11th, 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 1/11th all the way down. So this is 1/11th, that's 1/11th, that's 1/11th, all the way down. It's some nods saying yes, okay. But Josh said something different. He said, no, like before we just assume that, because what are you assuming? You're assuming 2 dice is just like 1 die. Which I'm not saying it can't be, but should we assume it's going to be that way? So here's one vote. Okay, vote number 1. Vote number 1 would be just saying it's 1/11th all the way down. Before you write any of these in your notebooks, let's put a bunch of the votes on the board and then see which one works. Now that sums up to 100%, doesn't it? 1/11 plus 1/11, 11 times is 100%. So that would work as far as that goes. Christina, what's on your mind up there? You said something else.
I'm thinking it should be 2/11.
2/11s? Where? Tell me
I
where.
don't know why. No, I'm just thinking it. I don't know if it's right.
Okay, I like what you're thinking though. I do. Amy?
I was wondering about
Two guys.
22,
What's 22?
like 22nd.
Why 22? I love 22. Why 22?
2 times 11. I mean,
So hang on. Here's PX vote number 2. Now I'm not saying you can't do this. I'm just saying that it might not be these dice that it works for. So you're saying,
Well, there are 2 different dice. Oh, you're talking about the total of...
yeah, I want to know if you go to Vegas and you're playing with dice like these, what behavior are they following?
Well, there are multiple ways to roll each number.
And that agrees with Josh, right?
Yeah.
So why don't we figure that out? Grab your dice. grab your dice, make snake eyes for me. Before we roll, we're gonna roll in a second, we're gonna roll in a second. Make snake eyes for me on your dice. Okay, make snake eyes, good. That's one way at least, right?
Right,
Make it again. A different way.
can't.
You can't, can you? You've made it one way and you can't make it any other way. Does that make sense?
Yeah.
Okay, good. What I'm gonna do, we're gonna build this kind of fragmentedly. I'm gonna put one over and then leave the bottom part blank for now. Does anybody know how many outcomes there are when you throw a pair of dice? You might, if you don't remember last week, you won't. If you remember your project from last week, you know the answer to this.
36.
It's 36. Do you remember that from last week? Because your first die can fall six ways, and the next die can fall 6 ways. Yes, very good. So you do remember. It's 1 in 36. There's only 1 out of the 36. Does everybody follow why it's 36?
Yes.
6 ways for the first die to fall, and then 6 ways for the next die to fall. 6 times 6 is 36. Now, in your project last week, I actually made you write all the outcomes out,
Yeah.
which we're essentially going to do again right now together in this table, in this tabular form. But the idea is there are 36 ways. Very, very good. And if you had a third die to roll, it'd be 216. Oh, we won't do that because it gets a little bit cumbersome doing that.
Yeah.
Okay? Okay. Make a sum of 3 on your dice for me, friends. Make a sum of 3 on your dice for me. Everybody got it? Make a different sum of 3 on your dice for me. Aha! You can this time, can't you?
Yeah.
This is why I told you to grab 2 different colored dice. So, if you have 2 on the white die and 1 on the red die, that's different than 1 on the white die and 2 on the red die. Isn't that 2 different? That would be 2 different sets of faces pointing upward, wouldn't it? It didn't. It did not work that way with snake eyes, though, did it? When snake eyes is 1 and 1, and I say make it a different way, you're not actually rotating the dice at all. It's the same 2 faces. Okay, so we've got 1 and 2, and 2 and 1. Any other ways we can do it? That's it for them, isn't it? That's it for them. 2 out of 36. Fair enough? Make 4. Make 4. Now, make a sum of 4, I should say. Make a sum of 4. Not 4 on one die, but a sum of 4. Okay, now do it again.
It's 4 times, right?
We're figuring it out right now. So how many can make 2 and 2 first? 2 and 2? Okay.
1 and 3.
1 and 3? 3 and 1? Is there another way you can do it? That's it.
Oh, it's 3.
It's only 3 ways. You can go 1 and 3, 3 and 1. You see where we're counting them twice?
Yeah.
Oh, because
2 different colors. When they're mismatched, you can flop the colors on it. But when it's a double, somebody said doubles, which is fantastic. Count the doubles.
So the even ones will have double.
Good, guys. We're looking for patterns. The even ones are going to have doubles, which means the even ones are going to have an odd number of outcomes. 1, 3. Very nice, Christina. Looking for patterns. I like that very much. Very, very good. Keep the pattern going. Keep it going. How many ways can you make a 5?
4.
Amber's got 4. That makes sense, doesn't it? 1 and 4, 4 and 1.
And I see a pattern.
You see a pattern? You do. It's very, very nice. 1, 4, 4, 1, 3, 2, 2, 3. There's no odd number because you can't make doubles. You can't do 5 as doubles. There's no 2.5, 2.5. Good. How about 6?
Maybe.
5.
5 ways, yes. 1, 5, 5, 1, 2, 4, 4, 2. Double 3s. That's called 6 the hard way if you're playing craps. 6, and apparently if you bet on hard way rolls, like 2 the hard way, 4 the hard way, 6 the hard way, it pays better. It pays better because it's harder to get. So it should have anyway, risk reward. We'll talk about that more on Wednesday too. 5, 36, 7. Good, Josh.
I think that's going to be 6.
We think it's going to be 6, huh? Count them out for me. Tell me the outcomes that make 7. 2, 5, 5, 2, 3, 4, 4, 3, 1, 6, 6, 1. Beautiful. All right, 7. Should be 736, yes?
Yeah, looks like that's the pattern.
Except
It's not?
it's not.
Oh. So it's not a
I
pattern.
love that, except it's not. Because the problem is
Isn't it
that it's, count them out. 1 and, oh wait, you can't do 1 and. You have to make a sum of 8, correct?
8.
There's no 7 on your dice. You
Oh.
can't go 1 and 7, see that's out. So you can get 2 and 6, 6 and 2. Christy?
So start counting down.
I think so.
Oh.
Because 2 and 6, 6 and 2,
3 and 4.
3
4
and,
three.
well, 3 and 4 is 7. We're making 8 now.
Oh, we're on 8?
So how about 4 and 4? Yes, we're on 8 now.
Oh, I thought
Because we had no one.
Because
Yeah.
you can't use 1 to make an 8. We got a lot. Just like you couldn't use 6 to make a 3. That's okay. That's okay. We like 7. 7 you win. 8 you don't necessarily win. So 8, let's see, 3 and 5, 5 and 3, 6 and 2, 2 and 6,
4 and 4.
and 8 the hard way, which becomes 5/36.
Oh.
So in other words, rolling an
Because
8
there's
is
less
just
numbers
like
to
rolling a 6. As far as probability goes, they happen just as often. Pretty rad, huh? According to this model. Okay, let's look at it. What about 9 now? 4 and 5, 5 and 4, 6 and 3, 3 and 6, 2 and, can't do 2. 2 is too small, there's no 7.
So it's only 4.
4 and 30, because they're typed over there. 4 and 36. How about 10? 3. There's 3 ways for 10. Let's count them. 4 and 6, 6 and 4,
5 and 5.
10 the hard way. 2 and, can't do it.
No.
3 and, can't do it.
No.
See, just like there were numbers that were too big to make these thumbs, there are numbers that are too small to make these thumbs. That's why it's trailing off. Somebody said, there was a new Christy that said they're going to start going back down. They most definitely are. They're going back down now. 11! 6 and 5, 5 and 6, 2 and 36.
1 and 30.
And then finally, boxcars happens one way. You gotta roll 6 and 6.
Yeah.
And lo and behold, when you add this up, look what you get. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So is that. That's 15 and 15 is 36 out of 36, which is 1. Now, question, of course, is, are we 100% sure this is correct? It's convincing. It's damn convincing. Let's test it. Let's test it with a quick anecdotal check. Take your dice, friends. Take your dice, throw them. Let's see what we get. Let's see what we get. I'll keep track of probabilities up here on the board. Or not probabilities, but frequencies. Let's just do a quick frequency count. Now you don't have to write this down. How many got snake eyes? Right then and there. Okay, nobody got snake eyes. How many got 3? A sum of 3, either a 1 and 2 or 2 and 1. We got 1. Okay, we got 1. How many got 4? Either 1 3, 3 1, or 2 4s. 1 2 or 2 2s. Okay. How many got 5? 5? How many got 5s? 6s. Okay. 1 2 3 4 5. How many got 7s? 2. How many got 8s? How many got 9s? Got a 9, maybe? 10? 11? Boxcars, 12? Roll again. Let's keep it going. Let's get some more data. It's a big distribution. It's a big distribution. Some of the probabilities are pretty small. So let's collect some data. Snake eyes! 3. 3. Okay. 4. One more 4. 5. Got a 5 this time. 6. Oh! 1 2 3 6. 7. 8. No 8's that time. 9. That's okay. It's okay. There, we got an 8 in there. Hang on, where was 8? 8's here, right?
Yeah.
This is 8, and then we got, how many 9s were there? I'm sorry. 1, 2, 2. 10. 11. Ooh. 12. One more time. One more time. All right, snake eyes. No snake eyes. We've got about, 20 people in the room, right? Ish. 20, 25 maybe. Let's call it 20 for to make the math easier. What does a 1/36 chance of snake eyes mean? You know, 1 in 36 chance of snake eyes.
36 rolls, you'll get it once, probably,
Add 2 more words to that, I'm happy.
on average.
On average, because we've already rolled at least 36 times, haven't we? We just rolled about 60 times, at least 60 times, and we didn't see it, so your neighbor's gonna get pissed. And he's gonna claim the dice are fixed. Because you, as soon as you roll 35 times and you haven't seen snake eyes, what's he gonna bet on?
Snake eyes,
And guess what you're gonna tell him?
don't do that.
It's my, you're gonna tell him, no, my friend. Don't do that. That's- what are you gonna tell him? No. No, back up. You're gonna tell him you're more likely not to get snake eyes than you are to. Very good, very good. Okay, no snake eyes. 3s. 3s? No 3s that time. 4. We got a couple 4s. 5s. Couple more 5s. 6s. 1, 2, 3, 4, 5. Very good. 7s. 1, 2. 8s. 1, 2, 3, 4. 9s. 10s. That was too much butterfly this morning. 11s and boxcars. Okay, so I think, at least based on our very quick, about 60 trials, we can throw out this distribution. It doesn't look like this is happening. Because if this were true, what would these look like?
Even.
Even.
Yeah.
There'd be the same number for each of them. So over the course of 66 trials, you would see 6, roughly 6 plus or minus in each category. What I'm seeing is, I'm seeing a huge glut in the middle here, yes?
yeah.
Yes, and if we continue to do so, I think we'd see it even more. As a matter of fact, I created a simulation of this because rolling dice is great. But if you're going to analyze rolling dice, it's so much easier to see a computer simulate it. Not that rolling dice isn't great. Next week when we play craps, you're going to be rolling dice to play craps because that's the important thing. In Vegas, you'd be doing